Hey, what's up, everybody? It's Mr. Murray here on Mr. Murray's Mathland. Today we are going to be working on those tan lines, right? It's the middle of winter, why not? And that means we're graphing tangent and cotangent graphs. So a lot of similarities in the process of how you space these things out, um, period, amplitude, midline, that sort of thing, with our sinusoidal graphs. So very similar approach, but a few key differences. One, let's get the idea of what the shape is, the parent function. So a basic tangent graph looks like this. It starts and ends with a vertical asymptote. So those are actually your x1 and your x5 of the 5 key points. And then in the middle, boxed in between there, you get this almost a cubic kind of looking graph there. And that's it. That's the tangent cycle, one complete cycle. And it will just repeat, like that over and over again in both directions. But a couple of key differences here is that distance from there to there of the basic tangent graph, that period is pi, whereas in the sine, cosine, secant, cosecant graphs, the period is 2 pi to start with. So keep that in mind. You're going to be working off a basic period of pi for tangent and cotangent. And the other key points, I said x1 and x5 are the asymptotes that begin and end the cycle. And then these are x2, x3, and x4. And x3 sits right on the midline. This is right where the middle of the graph is. Wherever that midline is, that's where everything gets shifted vertically. And the amplitude will represent, how far it's been stretched vertically. So how the distance of these 2 points away from that midline. So let's just jump in and try this problem and see it play out. And you'll see it's not so different than what we basically have been doing, just applying it to a different shape. So as we said, we are dealing with a basic positive tangent graph, which is this one. Positive tangent increases as you go left to right. The amplitude is that coefficient out in front, that's 1. The midline is y equals 2. That means we've shifted it vertically 2 units. The period, an important thing to watch out for, as we said, with tangent and cotangent, is pi over b. And so in this case, b is 1, right, that coefficient of x. So it's just going to be pi. So our increment, our distance between the key points, is going to be the period divided by 4. That's always the case. So in this case, it'll be pi over 4. Okay, now, here is going to be one big difference here is when you do a phase shift with tangent, watch out for this, right? When you set that equal to 0, right, you get negative pi over 4. That means we've shifted the graph pi over 4 units to the left. And that is definitely true. However, with the tangent graph, this value is the third key point, is the middle of the graph. So that means x3 is going to be negative pi over 4. Whereas normally with all the other shapes, when you get this value, what makes the inside quantity be 0, that's your x1. With tangent and not cotangent, as you'll see in a minute, only tangent, what you're finding there is actually the middle of the graph, x3. And we go over this in detail in class, like why this is, so I'm not really getting into that here, just the basic sketching here. So I'm still going to use this increment, which happens to be pi over 4 again, and I'm going to add it to get the next 2 key points. So I'll get 0, and I'll add it again, and I'll get pi over 4. And now if I want the other 2 key points, I'm just going to go backwards and subtract pi over 4. So that'll give me negative 2 pi over 4, or negative pi over 2. Go backwards again, and you'll get negative 3 pi over 4. So certainly a little bit different there to watch out for. The two things being the period is not 2 pi anymore for these, and when you set that inner quantity equal to 0, you're finding the middle of the tangent graph. Okay, so now let's actually put it all together here. The midline is y equals 2. Okay, so there's our midline. Let's space out these x values on the x-axis. Okay, we have an increment of pi over 4. So I think we should be able to go every 2 boxes is pi over 4. So that will be negative pi over 4, negative 2 pi over 4, or negative pi over 2, and negative 3 pi over 4 should fit nicely. There's 0, and there's pi over 4. Okay, and our beginning and our end, x1 and x5, are vertical asymptotes. Okay, there's 1, and there's 2. Boxing in this graph, our x3, this negative pi over 4, that is going to be right on the midline. So negative pi over 4, put that point right on the midline. And again, if you don't want to actually draw the midline, that's fine. It just gives me a center. At x2, at negative pi over 2, our amplitude is 1, and in the positive tangent graph, I'm going to be below the midline for that point. So I'm going to be right here, 1 unit below the midline, and at x3, which is 0, I'm going to be 1 unit above the midline. So right there, so I'm going to have this kind of graph here. I'm going to do my best to draw a curve through here. And, as you get close to these vertical asymptotes, your graph should be, flattening out, going vertical. Or there we go. Just going to label here, negative 3 pi over 4, negative pi over 2, negative pi over 4, and pi over 4. On the y-axis, this was 1, this was 3, 2 if you like. Okay. All right, so there's the tangent graph. Not too bad, right? And so let's check out our cotangent graph, and we'll see how it's similar and how it's even a little different than the tangent. So first of all, what does cotangent look like? The cotangent graph, very similar, starts and ends with vertical asymptotes, but positive cotangent, the basic cotangent, actually goes like that. And that's what the tangent graph looks like if you put a negative in front. So positive cotangent looks the same as negative tangent, a vertical reflection of it over the x-axis. So in this case, we're graphing a negative cotangent in this problem. So that's going to be starting and ending with vertical asymptotes, but a vertical reflection of that shape. So it's actually going to look the same as a positive tangent. This is going to be what we're graphing right here for this problem. So our amplitude, in this case, is 3. Our midline is y equals 2. Our period is, just like tangent, pi over b, and b in this case is 1/4, right? That's what's being multiplied to the x here. So that will actually give us a period of 4 pi, right? 1 divided by 1/4 is 4. So 4 pi, which means our increment, our distance between key points, will be that period of 4 pi divided by 4, which works out nicely. And each key point will be pi units apart. Okay, now be a little careful here, getting that phase shift. You can either factor out 1/4 or just set the thing equal to 0 and solve, which will give you x over 4 equals negative pi over 8, multiplied by 4, and you'll have negative 4 pi over 8 or negative pi over 2. Now with the cotangent, it is just like the sine, the cosine, and the other shapes other than tangent. Whereas, this represents a shift of pi over 2 units to the left, and that actually is x1. So x1 is negative pi over 2, unlike tangent where that value is x3, the middle of the curve. This is actually the beginning of the curve, the vertical asymptote. So now to get the other points with it, x2, x3, x4, x5, we're going to take that first point and add the increment, which is pi. And so pi over 2 plus pi is, negative pi over 2 plus pi is pi over 2. Add pi again, you get 3 pi over 2, or 1.5 pi if you prefer. Add it again, you get 5 pi over 2. Add it one more time, you get 7 pi over 2. So those are 5 key points we're dealing with in this problem. Midline of 2, amplitude of 3, so here's the midline of 2. Let's see here. Let's look at the spacing on the x-axis, negative pi over 2 all the way to 7 pi over 2. Well, I have enough space if I go 2 boxes for a half pi, so that's negative pi over 2, pi over 2. And then I have to go here, then that's 3 pi over 2. So I think I'm just going to go every box is pi over 2. I think that's what I have room for. So this is negative pi over 2. This is pi over 2. And that will be 3 pi over 2, 5 pi over 2, and 7 pi over 2. There we go. First and last with tangent and cotangent, vertical asymptotes always. Okay, x3, the middle point, is right on the midline. That's the same for both shapes, tangent and cotangent, so right there. Now, with negative cotangent, very similar to positive tangent, these are the 3 key points. And the amplitude tells you how far away to stretch those x2 and x4 away from the midline. So our x2 here, we're going to be 3 units below the midline. So the midline's at 2, so I'm going to put this at negative 1. That would be 3 units below that midline, right? And here at x4, 3 units above midline. We'll put you right there at a y value of 5. And we'll label that on the y-axis in a moment. And then we just do our best to draw a curve that goes through there. And the more it's vertically stretched, or depending on your scale and how you sort of spread things out, sometimes it's hard to make it look good. But you just try your best there. And that's not too bad. Maybe I'll just extend that vertical asymptote a little bit. There we go. So a negative cotangent looks like a positive tangent, and a cotangent looks like a negative tangent. So this is a y value of 5. This was a 2. This was a negative 1, and our x values are at negative pi over 2, pi over 2, 3 pi over 2, 5 pi over 2, and 7 pi over 2. So there we go. So a little bit different than the sine and cosine, but hopefully you got the hang of it from seeing 2 examples. If you need to see more, feel free to look them up, try them, check them out on Desmos, check yourself. Ask me if you got any questions, but hang in there and keep working hard, kids.